Okay, for the first two problems here, you can't really do without um, a protractor, um, something that kind of looks like this. I can go through the P here, and it has the two sets of numbers on it from 0 all the way to 180. So, and then we know this is, straight up and down is 90, and halfway in between is 45. So 30 degrees is going to be um, about right there. All right, so what it wants you to do is rotate everything 30 degrees about point P. So let's say point A is on the 30-degree line, and we need to move it 30 more degrees. Well, that means at 60 degrees, that's where it would be. It would rotate over to 60, okay? And B, let's say B is on 40-degree line. It has to go to 70 degrees because you got to move 30 degrees. So that's going to be up there. So that rotates to that position. So this would be A prime here. This would be B prime there. And C is on the 20-degree mark. So 30 plus 20 is 50. So it goes all the way up to the 50-degree mark right there. All right. So if you were to trace it, that's what you'd get. Pretty close to what we already have, but I know it's kind of hard to see, but I wanted you to see that's what we would do with our instruments if we had them. Same thing on this one, 150 degrees about point P. So point P, if we put it on this line here, and this line right there, 150 degrees. So G, let's say G is at, is on the, let's say 80-degree mark. 150 degrees would put it at 230 degrees. So you got to understand that's 90, that's 180, and that's 270, right? So, and then all the way back around is a full circle of 360. So you're at 80 degrees, point G is on the 80-degree radial. You add 150 degrees to it, that's 230. So let's see, 270 minus 40, which is about right there. This would be 230-degree mark. That's what we got to rotate this around, all right? And the radius of the rotation has to be the same. So that'd be G prime. And J, let's do F, I guess. F looks like it's at about 150 degrees, maybe a little bit more. Let's just say 150. So we rotate 150 more, that's 300 degrees. So 30 degrees past 270. So there would be 300, and we rotate it to there, that's F prime. And J looks like it's at about 210, 210 degrees, plus 150 would be 360. So J would go all the way to the 360 mark, J prime. Okay, and there we would have that triangle moved. It's hard to see on here. Let's move on. All right, so now we're going to actually do rotations like what's on your quizzes and tests here. All right, so graph the polygon with the given vertices and its image after a rotation of the given number of degrees. All right, so they're all going to be 90, 180, and 270. That's what we're going to be doing, and just like what we did in class. So you're just going to rotate your paper and write everything down. So I'm going to do it the exact same way on here. Number 5, let's plot everything first. -3, +2 is A. B is at 2, 4. C is at 3, 1. And so that's your triangle, okay? So what happens if we rotate 90 degrees? And we always go counterclockwise, all right? So we're going to rotate our paper 90 degrees. So we're going to face it so the B is far left and B and C are on top now. And I'm going to treat this like this was my y-axis and this is my x-axis to write these numbers down. So A prime, I'm going to try to write it sideways here. A prime, B prime, and C prime. Okay, so A prime is going to be 1, let's do it in blue. 1, 2, 2 left, so that's -2, and down 1, 2, 3, -3. And B prime is now at 1, 2, 3, 4 units left, and 2 units up. And C prime is at -1 and +3. So I rotate my iPad back around, and we plot A prime at -2, left 2, and down 3. 1, 2, 3. That's where A prime has rotated 90 degrees to. Okay, and B prime is at -4, 2. 1, 2, 3, 4, +2. That's where B prime rotated 90 degrees to. And C prime is at -1, 3. 1, 2, 3. And that's where C prime rotates to. So if we draw that, you can see how the pre-image, this is pre-image here, has gone to the image, rotated left. Next, graph the polygon. All right, so let's graph it. Everything's in the first quadrant, and it's going to go 180 degrees. So whatever quadrant it is, goes 2 quadrants to the left. So since all these are in the first quadrant, 180 degree rotation is going to put it all the way to the third quadrant. So J is at 1, 4. 1, 2, 3, 4. Okay, and K is at 5, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And L is at 7, 2. 6, 7, 1, 2. And M is at 2, 2. 2, 2. Okay. So we draw this. That's our quadrilateral. We're going to rotate 180 degrees, which means we turn everything all the way around, upside down. And now we pretend that this is our y-axis, this is our x-axis, and we're going to go ahead and say, what do we have here? J prime. And we're going to do K prime, and L prime, and M prime. All right, J prime, we'll do it in blue here, is at -1, 1, 2, 3, 4, -4, -1, -4. K prime is at 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Left 5 and down 5. L prime is left 7 and down 2. And M prime is left 2 and down 2. Notice when it's 180 degrees, all the signs changed. The X is all changed, the Y is all changed. Now let's plot them. So J prime should be at -1, -4. 1, 1, 2, 3, 4. So it rotated 180 degrees to this position. That's the only one I'm going to draw. K prime is at -5, -5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And L prime is at -7, 2. -7, -2. 6, 7, -2. And M prime is at -2, -2. And notice that everything's upside down, not reflected, rotated all the way around, upside down. Number 9, what'd they do wrong? The endpoints CD and R, C, and D there describe and correct the error in finding the coordinates of the endpoints of the image after rotation 270 degrees. So let's go ahead and do the problem. You're supposed to correct it, so let's just do the problem. C is at -1, 1, and D is at 2, 3. -1, 1, that's C, and D is at 2, 3. 1, 2, 1, 2, 3. So here's our segment. If we rotate it 270 degrees to the left, that's going to be 3 rotations, quarter rotations. And this becomes my y value, that becomes my x. So C prime and D prime is what I'm looking for here. So C prime is at, let's do it blue, +1 and up 1, so 1, 1. D prime is at 3, -2. Now turn it back around and let's plot them. C is at 1, 1, C prime, and D prime's at 3, -2. So this rotated 270 degrees. This rotated 270 degrees, and notice there's 90 more degrees to go to get back to where it was. So C prime and D prime. Now, what they do, so D, it says C prime's at -1, -1. Well, it looks like, I'm going to do it in yellow here, -1, -1 is there, and D prime's at 2, -3. Okay, so it reflected, that's what it did. It reflected over the x-axis. So that's what they did wrong. Instead of rotating it, they reflected it. All right, number 11, we have composition here. So let's plot the points. We're going to do 2 moves, and with a double prime. So x is at -3, 1. Y is at 4, -5. 1, 2, 3, 4. 1, 2, 3, 4, 5. All right, so now the first is a translation. We're shifting 0 left or right, but we are going to go up 2 units. So let's move everything up 2. That's x prime, and that's y prime. And now let's rotate it 90 degrees to the left. So I'm going to write, let's do this in red, x double prime and y double prime. Okay, so x prime is at 1, 2, 3 left, oops, and 3 down, okay? And y double prime, we're looking at the blue line now, okay? We shifted the black line to the blue, now we go from blue to the red. So we go from y prime to y double prime, that's 1, 2, 3 units to the right, and 1, 2, 3, 4 units up. All right, so let's plot those points, rotate your paper back. X double prime is at -3, -3. So this rotated 90 degrees. Notice it's gone one quadrant. Each quadrant's 90 degrees. And y double prime's at 3, 4. 1, 2, 3, 1, 2, 3, 4. And so that rotated up 90 degrees that way. So that's what your picture should look like. Number 13, do the same thing again, a composition. And -3, 1 is x, and y is at 4, -5. 1, 2, 3, 4. 1, 2, 3, 4, 5. Same one as the last problem. So that's your xy, okay? Oops. And now we're going to rotate first 270 degrees. So we'll do this in blue, 270 degrees. So this is our y-axis, that's our x-axis. And x is at 1, 3. So x prime is at 1, 3. Y prime is at 1, 2, 3, 4, 5, -5, and 1, 2, 3, 4, down 4. All right, let's plot those. Turn your paper back around. 1, +3. 1, 1, 2, 3. So that's x prime. Y prime is at -5. 1, 2, 3, 4, 5. -4. 1, 2, 3, 4. All right, so that is that segment rotated 270 degrees, okay? So now we got to reflect it in the y-axis. So we'll reflect over the yellow invisible line of the y-axis. So just count. X prime, you're 1 unit away, so x double prime, we're going to do this in red, double prime is there. And y prime is 1, 2, 3, 4, 5 units away, so y double prime is 5 on the other side. 1, 2, 3, 4, 5. So that is y double prime. Okay, there you go. Rotated 270 degrees and then reflected about the y-axis. So that reflected that direction, this reflected that direction. You don't have to draw those arrows. All right, same thing. Let's do it again. Composition time. These are definitely on the test. All right, so first we have the triangle L, 1, 6. 1, 2, 3, 4, 5, 6. M is at -2, 4. 1, 2, 3, 4. And N is at 3, 2. Now we're going to rotate 90 degrees. So again, this is our y-axis, and now this is my x-axis. 90 degrees, so L prime is at 1, 2, 3, 4, 5, 6, -6, and up 1. And then we have M prime is at 1, 2, 3, 4. Sorry, 1, 2, 3, 4, and down 2. Left 4, left 4, and down 2. So those are negatives. And N prime is left 2 and up 3. Okay, so now let's plot those points in blue. -6, 1. 1, 2, 3, 4, 5, 6, up 1. So 90-degree rotation, whatever quadrant they're in, they're going to be one quadrant to the left. So there's L prime. M prime's at -4, -2. 1, 2, 3, 4, 1, 2. And N prime is at -2, +3. Okay, so notice where the letters are. They rotated around. And now we're translating from here. We'll do this in red. 3 units left. So 1, 2, 3. And 2 units up. 1, 2. So there's L double prime. Same thing for the rest. M double prime goes 1, 2, 3, 1, 2. So that's M double prime. And N goes 1, 2, 3, 1, 2. Connect those, and there you'll see that it was an obvious shift left and up from there. Okay, does it have rotational symmetry? If so, describe the rotations. So what you're looking for is how far do you rotate it to get the picture to look identical to the way it does right now? Well, I can rotate it. I draw your chart through here. That's going to be a whole quadrant. That's 90 degrees. All right. And then I could rotate 180 degrees and I still get the same thing. So I can do the 90 and then I can also do the 180 and get the same thing. So there's two rotations. Anything more than the 180 is just a repetition of what we already have. So like you say, oh, we could go to the 270, but that's already covered with each 90-degree rotation. And so is 180, but they say anything 180 or less. So we'll count that and go on to the next one. All right, now a rectangle. This would have to be flipped all the way around to get to where it needs to be to go upside down. If it's a square, it'd be 90, but a rectangle, you got to rotate it upside down. So this only has 180-degree rotation. You can say, well, I can rotate it to there, but if you did that, then this would be your rectangle, which is not the same picture. All right, now this is an equilateral triangle. It says regular, so I know that means all the sides are the same and all the angles are the same. That's an equilateral triangle. That's what regular means. So here's how you do this. This is going to rotate to here, and it can also rotate to there and back again. So how many are there? How many corners are there in a regular polygon? There's 3 in a triangle. So if you take 360 degrees and divide it by 3, you get 120. Okay? Because if you drew a graph, there's 90, and you have to go another 30 more to get to that corner. So that's 120. So it's a 120-degree rotation. That's F. But how you do it is that right there. So F is that answer, and it goes past 180, so it doesn't have any other answers. Let's look at another one. Okay, so how many corners are there? Again, this is regular. 1, 2, 3, 4, 5. Again, if we kind of drew this in the middle here, this goes to there, and then to there, and then it passes 180. So if we take 360 and divide it by 5, 5 goes in 36 7 times, into 10 twice. So it has a 72-degree rotation. But that's this angle right there, 72 degrees. You could go all the way to that one. And how much is that one? 72 and 72 is 144. So it is both D and G. And then anything after that is more than 180. All right, so there's two answers on that one. All right, let's do a little bit of review. Let me blow this up a little bit. Just a little. Okay. Now, it says to graph the polygon. So let's start with 46. And -4, 1, 1, 2, 3, 4, 1. There's A. B is at -3, 3, 1, 2, 3. C is at -1, 2. And it says, now this is a review, it says reflect in the x-axis. So we're reflecting over the x-axis here. So A is 1 unit away, so A prime is going to be 1 unit on the other side. B is 3 units, so 1, 2, 3 on the other side. And C is 2 units, so C prime is 2 units on the other side. So there's your image. All right, 47. 47, let's draw our graph. All right, J is at -2, -3. K is at -1, 1. L is at 2, 0. And M is at 1, -4. Okay, now on this one, we are translating. We're going to the right 3 and down 2. So do it in blue, right 3, 1, 2, 3, down 2, 1, 2. There's K prime. L prime's to the right 3, down 2. M prime's to the right 3, down 2. And J prime's right 3, 1, 2, 3, down 2. And there you go, shifts right and then down. Good, 48. All right, 2, -1 is X, 5, 1 is Y, and 4, -4 is Z. So on this one, what we're going to do is rotate 180 degrees. So if you remember what I told you, the trick was just change all your signs. So I can look at this, and X prime is going to be at -2, +1. -2, +1. Notice it's gone 2 quadrants. 1, 2 to rotate. So that's X double prime. I'm sorry, just X prime. And Y prime is, we look at that, that's +5, +1, so that's going to be -5, -1. So -5, -1 is Y prime. And Z prime, 4, -4 should be -4, +4. Just change your signs. -4, +4. 1, 2, 3, 4. And notice that's rotation of 180 degrees. And that's it. You're all done.